It's kind of crazy to think that Model Context Protocol in less than a year has become the de facto standard of connecting tools to agents, which shows the significance of the MCP protocol and its usability for agentic era. Anthropic recently donated this protocol to Agentic AI Foundation, which is a new foundation created under Linux Foundation. The protocol itself is a lot more than simply connecting tools to agents. However, that is the main use at the moment. And that comes with a big issue of context bloat. So when you try to connect an MCP server that has multiple different tools to an MCP client, they end up bloating the context window of your client. Agents have a limited context window to work with. Just connecting an MCP server with several tools can occupy a major portion of it. That's before even sending a single message. So it's a major issue with the protocol itself. There are a number of approaches that people have proposed. We're going to look at some of those in this video. The first approach is code execution. So instead of loading all the definitions of the tools, you provide the agent with a sandbox environment where it treats the MCP server as a file system. This was introduced by Anthropic in this blog post, Code Execution with MCP, Building More Efficient Agents. So you start treating the MCP server as a file system, where each tool has a corresponding file like this. This does progressive disclosure and can substantially reduces the number of tokens that are in the context window of the agent. A similar approach is to use the tool search tool from Anthropic. In this case, the agent has access to some basic tools, and then it does search very similar to the file search that is done by Claude Code. This enables the agents like Claude Code to work with thousands of tools by dynamically discovering and loading them on demand. Now, both of these approaches are great, but they kind of move away from the original promise of MCP itself. And this is scoped loading, where you create groups of tools based on their similarities. So let's say you have an MCP server, which enables you to access a different niche data such as e-commerce, finance, social media, etc. Then you can create groups of these tools and dynamically load only a specific group based on your needs. This approach was introduced by Bright Data in their web MCP server. This is an open source MCP server built on top of Bright Data. A huge thanks to Bright Data for some of their amazing open source work and making this video possible through their sponsorship. Bright Data unlocks web data access, and they have designed tools which gives you real-time information, including data from social media platforms, e-commerce websites, and more. So as a result, they have almost 200 distinct tools for unlocking web access. Now, they came up with a very simple yet very elegant solution to address the issue of context bloat. And the idea is to create groups of tools. In this case, they have 8 distinct groups. Now, the implementation is open source. You can actually use this for your own MCP servers as well. In this case, when you're creating the MCP server, you need to define which group of tools you want to interact with. And you can also provide multiple different groups as well. This approach gives you very efficient token utilization. So for example, if you are going to load all the different tools, the tool definition itself takes about 7,000 tokens. For their specific server, the tokens saved can range from 60% to almost 94% compared to putting all the tools in the context window. You can take this one step further. So instead of defining a group, you can actually define a specific tool that you want to use for a given session. Now this is going to result in even more token reductions. This is again from Bright Data because they enable web level data discovery. However, your application may need to simply use However, your application may need just a subset of those tools. In this case, as an advanced user, you can select those specific tools and then you can provide them in your MCP server configurations that can be accessed by the agent. This approach gives you a lot more control, a lot more savings, and customizations, but you need to know the tools that are present on an MCP server. Now, the beauty is that all of this is open source. You can use the same learnings in your own MCP servers, and you get 5,000 requests per month as a free user, which is pretty great because Bright Data is a very reliable platform, and I personally have been using them for quite a bit. Another approach is dynamic context loading. This is inspired from Claude skills, which dynamically loads information and presents it to the agent as needed. So in the first level, we'd simply tell the agent what MCP servers are available. In the second, there is a list of tools and its summaries. And the third level is when it actually sees the name, description, and what is the input schema of a specific tool. This approach can not only save you the number of tokens, but also can help you make sure that the context window itself is pretty clean and it only has useful information. Now, the beauty is that you can combine this approach with the group tools or a custom tools approach from Bright Data. Another approach is a layered MCP server design. In this case, you have three different layers: discovery, planning, and execution between the LLM and the actual underlying MCP implementation. Think of this as a sub-agent design where most of the actions are happening within a sub-agent. So the context of the orchestrator or the original agent is pristine. It generates inputs and only gets results. Now, you can also optimize both the input and output tokens. So as we saw with the group tools, you already get a lot of optimization on the number of tokens. However, if you are looking at web data or data sets that have any sorts of formatting, usually these tools or web search results will return that formatting. But the LLM itself does not need that formatting. These are pretty smart systems by now. So you can potentially strip the markdowns or any sort of formatting and simply pass on the plain text results. And this approach alone can save you a lot of tokens. So one study by Bright Data found that just stripping down the markdown can result in almost 40% token reduction. And if you include light parsing with Google search results, you can get up to 80% token reduction. So it's definitely something very practical that you want to consider if you are implementing an MCP server with a lot of tools, which are going to be interacting with documents with formatting. No, in general, you shouldn't be relying on a single approach. Ideally, you want to stack these multiple different approaches together to get the most out of your context window. So do let me know which approaches you're using with your Model Context Protocol server tools. And please do share any tips you may have for the community. Anyways, I hope you found this video useful. Thanks for watching, and as always, see you in the next one.